Hello Cloud Pedagogians, welcome back to the course. We have learnt about IAM and how to secure the account in the previous session. In today's session, we will see how we can implement IAM service in our student directory application. Let's take a look at the application we are going to be building throughout this course. We have already gone over the design of this application, and what I want to do is focus now on the access control. There are multiple places on this diagram where we can identify the need for access control and credential management. The first thing we need to do is to manage how users log in and use the student directory application. We could require that people have a valid credentials like a username and password to log into the application. That is access management on the application level. Then there is the fact that we know the code running the student directory application is running on a virtual machine being hosted by the service Amazon EC2. That code will need to take API calls to the object storage service Amazon S3 in order to read and write data like images for the students. Well, here is the thing. Just because both Amazon EC2 and Amazon S3 have existing resources in an account, it doesn't mean that the API calls made from the code running on the EC2 instance to S3 are going to be automatically allowed to be made. In fact, all API calls in AWS must be both signed and authenticated in order to be allowed, no matter if the resources live in the same account or not. The application code running on Amazon EC2 needs access to credentials to make the signed API calls to Amazon S3. So that's another place with the need for credential and access management. Now let's take this a step further. How are you going to build out this architecture? Well, you will need access to an AWS account through the use of a login. Your identity within this AWS account will need permissions to be able to do things like create this network, launch EC2 instances, and create the resources that host and run this solution in AWS. Yet another place you need credentials. The root user, which you have already learned about in a previous lesson, has these permissions, but you don't want to be using the root user to administer your AWS resources. And also let's assume that you won't be the only one working on building out this application. It's more likely that within one AWS account, there will be many people who need access to build and support your solutions. You will have different groups of people responsible for different parts of the architecture. The people who would write and deploy the code might be software developers, whereas the people who would be responsible for making changes to say the network would be a totally different group of people. You wouldn't and shouldn't give everyone who need access to the AWS account the root user credentials to log in. Instead, you would have unique credentials for each person logging in. So this is where the service AWS Identity and Access Management comes in. We identify 3 places that we will need access and credential management for the solution. AWS Identity Access Management, or we call IAM, can help take care of these 2 spots on the diagram. AWS IAM manages the login credentials and permissions to the AWS account itself, and it also can manage credentials using to sign API calls made to AWS services. IAM would not, however, be responsible for the application level access management. The code running on this instance would use separate appropriate mechanisms for authenticating users into the application itself, not IAM. Let's start with the AWS account level. IAM allows you to create users, and each individual person who needs access to your AWS account would have their own unique IAM user. Creating users for everyone who needs access to the account takes care of the authentication piece, and authentication is nothing but verifying if someone is who they say they are because they logged in with the proper credentials. Now it's time to introduce authorization. Authorization is this. Let's say you have logged in and you are who say you are. You have been authenticated. Now you want to create and manage AWS resources like create an Amazon EC2 instance, for example. So sure, you have logged in, but do you have the correct permissions to be able to complete that action? The idea that your permissions control what you can or cannot do is authorization. Are you authorized to launch an EC2 instance? IAM users take care of the authentication and to take care of authorization. You can attach an IAM policy to a user in order to grant or deny permissions to take specific actions within an AWS account. And keep in mind, when I say action here, I am referring to an AWS API call. Everything in AWS is an API call. IAM policies are JSON-based documents. Let's take a look at an example. This IAM policy document contains permissions that allows the identity to which it's attached to perform any EC2 related action. The structure of an IAM policy has an effect which is either allow or deny and action which is the AWS API call. In this case, we have EC2:** which that would include all of the EC2 related actions. You can restrict these to be specific API calls too. For example, I can restrict this action to be just run instances, and then any user with this policy attached would be able to run EC2 instances but perform no other EC2 related tasks. IAM lets you get very granular with your permissions in that way. We see the resource which allows you to restrict which AWS resources the actions are allowed to be performed against. You can also include conditions in your policies that can further restrict actions. IAM policies can also be attached to groups. IAM groups are nothing but simply just a grouping of IAM users. You can attach a policy to a specific user or to a group. When you attach a policy to a group, any users that are a part of that group would inherit the permissions. We recommend that as a best practice, you organize users into groups and assign permissions to groups instead of individual users where possible. This makes it easier to manage when people change job roles, or maybe multiple users need permissions to be applied or revoked. Another best practice to follow is that we recommend when you create your AWS account, we first set up MFA for the root user. Then create IAM user with administrator permissions, log out of the root user and then log in with the new IAM user that you just created. From there, you can use this user to create the IAM groups, users and policies for the rest of the people using this AWS account. The reason you do this is because you cannot apply a policy to the root user, but you can to an IAM user. Now, I have told you about IAM users, groups and policies. So we address this part of access management that we needed for our application. But what about this part? The EC2 instance needs credentials to be able to make these signed API calls to S3 for reading and writing students' images. Do you think am I suggesting that you make an IAM user with a username and password for the application running on EC2 to use them? No, I'm not gonna suggest that. This is where role-based access comes into picture. Coming up next lesson, we will learn about the temporary access that IAM rules provide and how it can be applied in this use case. I hope it's not too long before we see again in my next video. Until then, bye.